Good morning, good afternoon, and good evening, everyone. My name is Prasanna Venkatesan. I'm a director in the Digital and Internet of Things space at the Industry Solutions Group in Oracle. Topic of my presentation today is on digital fleet and freight management. Just a brief introduction to myself. I've spent about close to 7 or 8 years now in the IoT space. I have fairly extensive experience in multiple industries. I'm more of an IoT practitioner. I first got started in the IoT space, more in smart grid, really, on utilities. And I was one of the founding members of the Cisco smart grid team. And eventually at Cisco, we wrote the business plan to morph it into the IoT, or the Internet of Everything, as we called it, team back in 2012. And since then, I've been working with a multiple number of industries, everything from process industries to manufacturing, mining, oil and gas, and of course, utilities. For the past year and a half, I've been at Oracle leading our digital and Internet of Things space in our Industry Solutions Group. With that, let me get started with the topic today. If you look at a very dynamic and digitized world today that we live in, companies need to move people, they need to move goods. There are shippers with products, logistics companies with fleets of trucks, service companies, hundreds or even sometimes thousands of field technicians, or even you can take your own public transit bus system or emergency first responders. They're all faced with a dilemma today. How can you enhance your customer's experience, whether it be the status of your cargo, keeping your fleets properly maintained, your people and buses moving on time, giving people status updates, and how do you use the best possible processes and technologies to ensure that you don't drop the ball for your customers? So that is really how we are going to look at today's topic, and on how you can leverage digital and IoT technologies to your competitive advantage. So that's going to be the topic of our presentation today. So a few caveats before that. I'm an engineer by training, a fairly optimistic one. So there are some forward-looking statements that I will be making today. Let's look at fleet operations. So if you look at today's fairly dynamic, technology-driven world, the pace of reaction is very much faster. Both fleet operators and large users and shippers, there are fairly big forces that are shaping this space. E-commerce is one of the largest drivers of change in the market today. New shipping patterns leading to higher levels of unpredictability, which in turn is leading to softening demand, especially for large carriers where warehouses are built. And in general, there is fairly excess capacity in pockets of the market today. One interesting tidbit, did you know that if a customer is looking at a product on Amazon.com for more than 15 minutes, it automatically triggers a movement of that product to a warehouse that is actually closer to that particular person, so that it can be shipped and delivered on time, especially if that person is a prime customer. And the second one, there is an instant gratification culture among customers today. It's leading to more of the shipping moving to smaller local delivery modes. For other segments of customers, such as those shipping sensitive goods, they want to know where their goods are at all times, when will they arrive. And of course, who amongst us has not waited for a cable technician to arrive, and we waited the whole day, and sometimes they will show up at the beginning of the day if we are lucky, and sometimes at the end of the day. So all of that is naturally not contributing to a fairly conducive experience for customers. Lastly, when you look at North America, not just North America, actually, pretty much the rest of the world today, a full employment economy and inflation, which is kind of beginning to rear its head a little bit, they're all leading to increasing costs of inputs from everything to parts, spare parts, to labor, which is further squeezing the profits of fleet operators. And pretty soon you will see that it's actually being passed on to shippers and others as well. So those are all things which are actually happening in the market today. Let me actually give you some level of statistics to drive home the point on how digital transformation is actually accelerating and influencing change in the transportation and logistics industry. While some sectors are obviously changing faster due to digital influence than others, the pace of change is really accelerating pretty much across the whole market. Firstly, when you look at the left, there was a CNN Money study that was done where just for US residents alone, $38 billion being wasted every single year, just waiting for goods to be delivered, service technicians to show up, etc. So as consumers of mapping services, for example, we get up to the minute arrival times from our smartphone GPS and applications. Why can't shippers and recipients get the same information and make their operations more efficient? There's not very many reasons why it couldn't happen. Second, if you look at that $38 billion, people are actually willing to pay for this experience and this convenience. There was a Business Insider report which said that 40% of respondents to their survey were in fact willing to pay for same-day delivery services. So while this perpetuates obviously the whole on-demand culture and instant gratification culture that is taking hold, it is also an indication that people are willing to pay for the services that value their time. And on the left-hand side, the last one actually, which I wanted to also share, is that there is also a cost to the environment, not just a cost to operators themselves. When you look at fuel that is being wasted because of unnecessary idling, and this is only the tip of the iceberg, I've actually had real customers of mine who have been able to pay for entire projects, consulting projects and implementation just based on fuel savings alone. I obviously can't name names, but especially in the mining and process industry space, this is quite prevalent. And when you look at the right-hand side, the number of connected vehicles, non-passenger vehicles specifically, by 2020 exceeding more than 20 million vehicles, the amount of data that is, or the digital exhaust, as some people term it, which is being produced per day by an average vehicle, the estimates by 2025 exceeding more than 30 terabytes. And finally, even being able to use a small part of the data to drive a fairly well-nuanced use case, a well-understood use case, even though it is, I don't mean to say that it is not a complex undertaking. The cost benefit derived from proactive fault detection is really exceeding 20%. This is according to DOE estimates, Department of Energy estimates from the US. So this is all real value that can be delivered by digital technology today. So let's look at what is really the pressure that fleet managers are under. So there, obviously, as I mentioned, there is cost pressures that are going. We know that this doesn't mean that shippers and logistics companies and fleet operators are out of the wood yet, even though digital technologies are becoming much more prevalent. There are serious issues today that keep CFOs and CFOs up at night still, whether it is to improve your fleet utilization rate, get a better handle on reducing your operational expenses of maintaining and running a fleet. So there are also shippers are not letting fleet operators off the hook either. So they are demanding much more accurate ETAs or estimated time of arrivals so that they can schedule their own operations better and protect even sensitive cargoes such as pharmaceuticals or foods that need to be refrigerated. You want to ensure that you have a fairly secure supply chain so that you're not faced with a potential recall type of scenario or situation later. And why do we believe that Oracle and other cloud-based solutions can deliver this value? And the truth of the matter today is that there are potential legacy fleet management solutions that are there, but they are not yet innovating as fast as customers demand in the digital realm. You have these 4 to 8 hour windows that are still the norm. One distribution center customer told us actually that they get updates on fleet shipments twice a day at best. And when you're running a warehouse or a distribution center that only gets twice a day updates through EDI or other legacy technologies, you can just imagine if an inbound shipment is delayed, that results in lost revenues with their downstream customers, not to mention an inconvenient disruption to their own operations. And little is really being done to automatically identify and reward the best drivers. As I mentioned, there is a labor shortage actually that is happening here. And in order to retain your best drivers, which is actually resulting in a higher turnover and pretty big retraining costs as well. Finally, the way that most companies today are handling alerts is to use simple threshold-based indicators, by which time it's probably too late already to avoid a disruption. With capabilities that exist today, much of this disruption can really be avoided by using more predictive capabilities that come with digitization. What does the Oracle Digital Fleet Management solution do? This is actually a much more nuanced and cloud-based solution to address the challenges of fleet operators. There are three things that we are going to be able to do. So first one is to track and detect. Second is to visualize and predict. And finally, to integrate and to act. With the digital fleet and freight management solution, you can actually track and detect your cargo, your fleet, and your personnel at all times, which is really laying the foundation for a much more efficient operation. It can help you visualize and predict the status of your fleet in advance before a disruptive event actually forces you to get into a reactive mode, spend more money and resources, which is fighting a fire that you probably don't need to. And finally, with a full suite of integrations to Oracle's leading edge Oracle Transportation Management Cloud, there is actually much more assurance that we will not force you to keep jumping between multiple business processes here and there to run your own business, which is what we used as the foundation for building this entire solution. There are obviously things over here which I am going to talk about, which are still on our roadmap from a demo standpoint, but it will hopefully give you an idea of where digital fleet and freight management is going today. Okay, the first thing that we're looking at on tracking and detecting, this is actually targeted more towards fleet managers as well as logistics shippers, actually, who need to know at all times where their cargo is, or their tractors, their trailers, their buses, or other vehicles might be. What is their most current status? This has direct relation really to multiple downstream effects. Everything from driver KPI management, for example, which of my drivers are following safe practices, which ones aren't. Customers' cargo management, where is my customer's shipment? Is it on, which truck is it on, under which conditions is it traveling on? Is it on track for the promised delivery window or not? Do I need to notify my customer, etc.? And lastly, location management. Have any of my vehicles left their intended trip route? Have they missed a waypoint that they were supposed to be at a certain time? Does this have downstream implications again to delivery of goods or services? All of that can be done with this first capability that we have over here. Next thing that we look at is predicting events before you can actually have a disruption in your fleet. So with the power of a much more connected digital fleet management system, it's actually possible now to use predictive analytics to deliver a fairly superior customer experience and avoid disruptions at the same time. When customers, whether they be passengers or shippers or those expecting a service technician, they demand to know an accurate ETA. And digital fleet management can actually now allow you to combine multiple sources of data, from routing to price stops along the route to live traffic to arrive at a much more accurate prediction. You can even arrange workflows and notification systems when advances or delays actually are cascading downstream, so that shippers can be much more aware of what is going on. Because digital fleet management can ingest a lot of data from onboard diagnostics on vehicles, there are commonly known protocols, SAE J1979 for light vehicles, SAE J1939 for heavy-duty vehicles. You can actually deliver advanced warnings of impending equipment failures, which can allow operators to take corrective action before a failure becomes disruptive. Just think of the time, the money that can be saved waiting for a relief truck to arrive while perishables are rotting in the back of the truck because the HVAC unit on a reefer truck failed. The savings just from such scenarios are tremendous. Tires are another thing. Tires tend to be one of the largest consumable expenses outside of fuel and labor cost, of course, in the operation of a vehicle fleet. And when you look at each tire, the life of each tire, which can be retreaded multiple times over its life to extend its operating life, you want to make sure that you get those tires back to a retreading facility at the most optimal time. With predictive analytics, you can make it much more easier now to tell when exactly a tire will reach its optimal wear and tear, so that you can take that out of service for retreading and then put it back on your fleet again. This is just one of the use cases, obviously. There are multiple such use cases you can enable with digital fleet management. And lastly, integrating and responding. Easy integration, category leading SaaS applications such as Oracle Transportation Management, CX services. You can actually, and I don't mean to just make it into a pitch for things that Oracle does. It's just much easier because I understand my own products better. But it is easily possible to connect to other, even our own competitors' cloud services as well. when you look at digital fleet and freight management. You can respond much better when you have that core digital capabilities with prescriptive actions that can enable you to stay on top of your own operation. So with responsive analytics, you can actually publish leaderboards and have gamification and rewards for your best drivers. You can provide coaching tips pretty much in real time. You can provide even nudges for the rest of them to improve. This is a much bigger and trending topic, obviously, the whole nudge unit that multiple governments have actually set up. In fact, Richard Taylor, a pretty famous behavioral economist, just won this year's Nobel Prize in Economics for this exact same concept. And second, with integration to OTM, Oracle Transportation Management, with CX services, you can even arrange workflows and notification systems when advances or delays are going to cascade downstream so that customers can be made aware. And lastly, with access to driver and customer schedules, you can actually plan your maintenance windows much more intelligently so that your fleet utilization remains higher, which can then increase your bottom line. So with that, I'll actually now transition to a demo. I know I've gone through a whole bunch of slides and you're trying to see what exactly is this whole digital fleet management really about. I'm going to transition to a demo. The demo is actually, I've taken some live screenshots from a demo that runs in the cloud. So we're going to just walk through that. Okay. So the demo has a few different personas in this particular scenario. We're going to talk about an integration between a shipper who is actually a logistics customer. We're going to look at a fleet operator who is operating this whole IoT fleet monitoring dashboard. They own multiple vehicles. And then you're going to look at a driver himself, who's actually the operator of the truck. So we're going to start here with this shipper persona here. This is a lady, Julia Meyer. She's a shipper. She is shipping goods here. This is actually the Oracle Transportation Management dashboard, of which you see a screenshot here. And if you look at the shipment starts here in Reno. It's the pickup point, the origin really. And then it progresses through. It has a couple of stops along the way before it goes over to the California side of the border and ends its shipment in Truckee. So you can see that this is the particular shipment. You can see the shipment status. It's en route. It's not yet started. You have multiple stops along the way, and it gives you planned arrival times, etc. And it tells you when exactly it is supposed to arrive. So this is Julia. She is monitoring her shipment, which is going from one place to another. Naturally, for the sake of the demo, I'm just looking at one particular shipment here. There will be potentially dozens, if not hundreds, of these shipments that could be going on at any particular time. The next page in Julia's dashboard, if she clicks on that shipment ID that she saw there, it actually gives her more information. It tells her who is the provider of that shipment. It tells her who is the driver of that shipment, what is the cost, what power unit has been assigned, more details really than she potentially might care to know about, but these are all data that are available and information that is available to the shipper if she actually wants to look at it. Then if you want to look at the equipment that is assigned to the shipment, it's a dry van that is assigned here. You can look at all the different stops, the planned arrival times, planned departure times, distances between stops, etc. So again, a whole bunch of information. Now we're shifting a little bit to the fleet manager persona. And this is Lady Lisa Jones. She's got these vehicles in her fleet here. Oops, excuse me. She's got these vehicles in her fleet here. 3 vehicles, what is the availability of that fleet, how many are utilized, how many incidents are ongoing, how many active trips, the fuel cost, which is actually a running gauge for her to look at, as well as violations. So these are all data that she is, Lisa Jones, who is the fleet manager, is using in order to manage her fleet on a day-to-day basis. And then let's lastly look at Jeff Warner. Jeff Warner is actually our driver. He's the one who's actually going to be driving this truck here. And this is a simulator that we built because naturally we can't drive from Reno to Truckee whenever we want to do a demonstration. So we actually are using an IoT simulator, which is actually simulating your different speeds of your truck, your engine RPM, number of diagnostic trouble codes, etc. Pretty much everything that you get from onboard diagnostics port. A few of those have been sampled and displayed over here. and it also gives you an updated location of lat long, speed, etc. So let's look at Jeff Warner once he starts the journey. You can see that the truck has actually started. The status of my simulator is on. And naturally, Jeff feels that he's probably running late. So he starts stepping on the gas a little bit over here. So he is speeding. So you can see that the truck is actually doing more like 80 miles per hour. Certainly not someone that I want on the highway with me. So this is Jeff. He's trying to go from one place to another in the quickest possible time. Now, this is obviously outside the realm of normal operation. And because he's doing this, and it's a fairly mountainous area, his engine is actually now overheating. And this in itself is going to send a code back to Lisa Jones, because she is now going to be aware that the engine is actually in an overheat status, and she can actually intervene. And if she intervenes, great, which is going to save you a little bit of trouble here, because all of this is being monitored in the IoT cloud as well. But if she doesn't, then it could potentially lead to a vehicle breakdown situation, which is something that you see here, where the truck is actually stopped and you'll have to swap out the power units, which is then, again, things that can, as we mentioned in the beginning part of this presentation, there are cascading effects now downstream, which we are going to see how those things can actually play out. So let's look at Lisa Jones's dashboard. So she's actually clicked into Jeff Warner's routing information here. So you can actually see these dotted line, which is actually the planned route here. So I started the simulator somewhere in the middle of the journey rather than starting in the beginning. So she can actually, Lisa Jones can then see how many incidents have actually been generated already, because you already saw that, first of all, he was speeding. Secondly, he was also overheating his engine and did not pay attention to it, or Lisa didn't catch it in time, which has now led to a vehicle breakdown situation. So all of that information actually comes down to Lisa, where she can actually see that the engine overheat condition or the vehicle breakdown situation are both being flagged as fairly medium to high priority situations that she now needs to take care of. So when you look at this cascading effect that we spoke about, where it's actually going to, now normally when you have a fleet operator, and I'll give you a little bit of context for this, is when you have a fleet operator that is such as Lisa Jones, who, so we'll go back one slide, who is actually faced with this type of a situation, pretty much everything that needed to be done in order to push this information to a shipper was either happening in a batch mode, or it was a manual intervention process to let the customer know that, hey, shipment is probably going to get delayed, might want to plan some contingency measures while it's doing that. But because you have IoT and all of this is actually running in the cloud, and you're able to make these cloud-to-cloud connections between Oracle Transportation Management and the IoT fleet monitoring applications that fleet operators have, you can actually transmit that information pretty much on a real-time basis over. So you can see that Julia Meyer has actually been informed already that, hey, somewhere between here and there, this is where my driver is currently located. There is actually a delay in my shipment. So shipment is en route for sure. So it has already left its origin. It's on my way to the destination, but it's actually delayed because of this breakdown situation. And when you look at her estimated arrival versus actual arrival times, you can actually see that the shipment, which was supposed to show up at 13:55, really is going to show up or has showed up only at 15:10, which is more like 3:10 in the afternoon, instead of 5 minutes before 2 o'clock in the afternoon. And you look at the third stop, again, this is a fairly short stop. It was also delayed, and you have this cascading information. And lastly, that cascading information, the delay has also been transmitted to the final stop. So it was supposed to show up originally at 2:22 p.m. It was now delayed to more like 3:37 p.m. in the afternoon. So Lisa, who without having to lift a finger, she's the fleet operator, has been able to automatically transmit an information about her fleet delays to Julia, who's the shipper, who's now going to be able to plan certain contingency scenarios to make sure that nothing goes wrong in her own operation. She may be running a distribution warehouse, she may be running some other type of logistics operation, or she may just be the recipient who has to schedule a dock to be available when the shipment shows up. She knows that it's now not going to show up and it's actually a little delayed. So this is all fairly useful information, which is automatically being transmitted over to your customer side. And lastly, just for fun, we also did Geofence Violation, because you have GIS coordinates that are now coming from your trucks as well. So geofence violations, these can be something as simple as, hey, there's a lot of traffic along my planned route here, so I decided to take a deviation through the mountains over here. Or it can be something even nefarious where somebody's actually hijacked your shipment. And again, these are all real use cases. I know some of my customers have actually told me about some of those use cases where some of their trailers go missing on a fairly regular basis. So there are write-offs associated with that pretty much every single year. So if you have these geofence violations, you can actually take some more concrete actions before you realize at the end of the year that there are some things now missing from your fleet. So in this case, Jeff Warner has driven off of I-80. You can see that he's actually driving along the mountains here rather than going along the highway, which again lets Lisa Jones, his fleet manager, know that there is actually a deviation in this particular case. And you can see that the vehicle has deviated from route, and now that GIS coordinates have been transmitted to her. And she may decide to wait and watch, and she can actually, if it does not return to the location, she can actually then potentially call Jeff and see what is going on to make sure that everything is okay. In this particular case, as we suspected, it was merely something where he had to take a small deviation, potentially due to a traffic situation we don't really know. But he's back en route, so Lisa is not going to do much about it, and the shipment is continuing on. But you will notice, by the way, that at the end of the demo here, once everything is completed, all of that information is actually going to get transmitted over to the shipper as well. And when the shipper then sees his or her shipment, you can see all the planned arrival times, the estimated arrival times, and the actual arrival times, all populated automatically once the shipment is completed as well. So with that, you can actually see the full power of IoT being integrated with different types of business processes, in this case, a logistics and shipment process, which is really where IoT makes its power known. My philosophy, and in fact, a lot of practitioners are also realizing this, is IoT by itself, when you look at different, I call it the 3 phases of IoT. The first one is really connectivity, which obviously gives you, just from visibility into your assets itself, a huge deal of information. What do you do with that information, which is the second phase of IoT? Here you can actually do things like predictive analytics, predictive maintenance, and a whole bunch of other things, potentially to see how everything is working together, which is, again, more useful than just having visibility. But the last piece, which I call integrating and acting, which is really connecting this data, this IoT data, into your business process, like we've shown here with logistics. That is where IoT moves from being just another cool project or another data source to becoming an indispensable part of your operations, without which you will have a much more or a much less efficient operation, if you will. So just in this case alone, you could have seen that if Lisa had to pick up the phone and call Julia and let her know, it's a much less efficient operation than having a cloud-to-cloud connection between the two companies. So in summary, digital fleet management or digital freight management, it will help you improve operations now and position your company and potentially others, your customers as well, depending on what type of persona you are, and much more attuned to the future. And we are just barely scratching the surface. We have not spoken about autonomous vehicles, truck and cargo. I think Tesla is coming out with its announcement of an electric truck, and I'm pretty sure after that there are going to be more such announcements. Otto, which was OTTO, which was a company that was actually acquired by Uber, which gave them capabilities in the autonomous space, was actually an autonomous trucking company. So those are all things which are naturally going to come. But what we can do to get ready for the future is get much better situational awareness into your fleet and your freight in real time, improving fleet performance and efficiency to have a much better OpEx handle on your OpEx. And lastly, to build a better digital experience with your customers, between employees and operators as well. So with that, I will close my formal prepared part of my presentation, and then I'll move now to the Q&A part, and we'll be happy to answer any questions there. Okay, Rahul asked, are there recommendations for fleet data frames? I'm not actually entirely sure what you meant by fleet data frames. Is this something to do with OBD data that is coming back, or did you mean something else? If you don't mind, just letting us know. And does it provide JSON strings at predefined intervals? Yes, it does depend obviously on the dongle, on the data dongle, or the type of onboard diagnostics data that you're going to be able to provide into the IoT simulator. So JSON from the simulator, yes, so JSON from the simulator is available into the IoT fleet monitoring applications. Yes, that is correct. And I encourage you to take a look at cloud.oracle.com/IoT-apps. That is a place where you will be able to explore more about the IoT fleet monitoring. What type of hardware integration is used? What type of hardware integration is used on this demo? Does the hardware run off the shelves or custom? So in this case, so the dongles themselves that go on the fleets, there are n number of customers who actually, or technology partners rather, that can provide that level of information. In fact, it's becoming so common now that even Samsung at the 2016 CES, not even 2017, 2016 CES announced a dongle costing less than $100, which has everything from OBD2. It can read your onboard diagnostics. It can provide you with a Wi-Fi hotspot, and it has a cellular backhaul connectivity as well, all for less than $100, which is now available through AT&T. So, n number of hardware companies which are providing that already. It's pretty much available off the shelf. Are the simulators platform agnostic? The simulators actually are written in Java, and they do run with the Oracle Java Cloud Service. So in this case, I want to say platform agnostic, but in this case, they run on the Oracle Public Cloud. So currently, no, they do not run today with. So the question was, can the simulators work with AWS and GCP? From an integration standpoint, yes, there may be certain workloads that you may be running on AWS, Azure, etc. We don't particularly care, although we would love it if you run it on the Oracle Public Cloud. But as I mentioned, currently the simulators all run on the Oracle Public Cloud. So I can actually give you the URL, so if you want to check it out. So Nitish asks, can we write business rules, maybe complex with interdependencies? Absolutely. You can. So you can write any number of interdependencies. All of these are run through APIs. And Oracle Transportation Management is a really robust and extremely capable. It's actually the leading transportation management software as a service in the Gartner management, or Magic Quadrant rather. So it's been around for a very long time, and pretty much, I would say, just going to one of the customer advisory board meetings was a revelation to see how much how much of the user base is really steeped in that. So yes, absolutely, you can write any number of complex interdependencies. By the way, not just in the transportation management and the shipping and logistics part, but you can also write it on the IoT fleet monitoring application, which is, if you go to the cloud.oracle.com/IoT-apps, which is the link I provided there. Oracle IoT Fleet Monitoring also has a bunch of rules that you can actually write, as I had shown in one of the slides there for the Geofence violation. So you can actually do dynamic geofences. You can do hard-coded geofences. So to give you an example, you may want to draw, let's say you have regular deliveries that are being made to a certain distribution center. You can draw a geofence around the distribution center so that you can say, hey, send me an alert whenever my truck is within 5 miles of this particular distribution center, so that I can then text my customer that this truck is arriving within the next X minutes, so that they can keep the dock ready, so I can get my truck in and out in a particularly fast amount of time. So you can do any number of these complex rules. So it's really powerful when you run things in the cloud. Rahul asks, does Oracle have a front-end intelligent gateway for Edge? Definitely. If you just Google Oracle IoT technology partners, you will find a number of these partners, everybody from Cisco Systems to Advantech to Dell. We have actually tested the Oracle IoT client libraries on all of these edge gateways. CY Leong asks, does this application perform any analytical solutions, example, save cost on route, energy, etc.? Yes, you can. So when you look at Oracle Transportation Management, we do have mapping providers that are already integrated into Oracle Transportation Management. The license is, of course, separate for that, depending on who you really want to use. So everybody from Nokia here to others are actually part of the suite already. So all of them today have things such as routing capabilities, most efficient routing capabilities, hazardous cargo routing capabilities, etc. So you can actually do those routing, etc. on either you want to avoid toll roads, or you may want to avoid high traffic areas, or there may be certain situations in your cargo. Let's say you're doing some fairly sensitive cargo shipment and you want to be able to avoid certain routes. So you can actually plan for any number of routes if you want to do most efficient routing, saving on fuel, etc. So yes, CY, you can do that. Gopi Krishna asks, in the fleet management, what is offloaded to the edge? Actually, you can offload certain things to the edge. It really depends on what you want to do in the cloud versus what you want to do in the edge. And this is where, with a lot of analytics capabilities that are already integrated in IoT, fleet monitoring and the IoT platform as a whole, you can develop algorithms with stream analytics. You can run those algorithms either in the cloud itself or for fleet operators, particularly because not everyone is going to have a fairly robust LTE connection to send that data back at all times. You may want to run certain algorithms in the edge. So for example, driver coaching algorithms, you may want to run at the edge because you don't want that data for a hard braking or a hard cornering incident to come back all the way to the cloud. There are latency issues that might be involved because of your network connectivity effects rather. And then sending the data back. So you might only be able to give a beep or a warning to the driver 10 seconds after he's had a hard cornering incident, by which time he might have even forgotten it. So you're not going to be able to provide that in context. So certain things you may want to offload it to the edge, such as the driver training algorithms. Whereas the rest of it, where you might be ingesting certain data for developing your algorithms around predictive analytics, those are things that you might want to send back into your cloud because you're doing certain type of algorithm development with them. Rahul asks, if data connectivity breaks, location data is stored on dongle or gateway? Answer is yes. It depends, really, because certain dongles may not be having the connectivity themselves. They may have a gateway style of connector where the dongle is actually transmitting to an onboard gateway, and then the gateway is maintaining that connectivity back to the cloud. Whereas there are other dongles, like Samsung being an example, where it can actually directly communicate with the Oracle cloud by itself. So it depends on how your system is architected. But naturally, you would want certain storage capabilities at the edge. So instead of dongle or gateway, I'll just replace that by the word edge. And you can store that data and send it back when your connectivity is back. Let's say you're driving in the Grand Canyon and you're not having good cellular connectivity, then you may want to then store it at the edge at the dongle or the gateway. But both of those capabilities are available. CY asks, does it have emergency recovery security, including hard shutdown, disruptions, etc.? Yes, absolutely. The Oracle Cloud is indeed architected with multiple redundancies, as pretty much what you would do in a cloud architecture. So the answer is yes. Gopi Krishna asks, does the platform support managing and orchestrating the edge, and what functions are offloaded? This is probably a question that I might have to defer and get back to you on. If you don't mind setting up a one-on-one with me, I'll be happy to get that answer back to you. Oh yes, CYS, I meant on the so for example, CYS, does it have emergency recovery security, including hard shutdown? Answer is yes, by the way. So it honestly would depend. So I don't want to make mega promises here, and I don't think the intelligence currently that is being developed today is at a level where it is already available, but I don't see why not. Because if you think about certain rules and algorithms that could potentially be stored in your edge gateways. So, for example, very hard acceleration, sudden braking, again, very hard acceleration, which you would probably not see under a normal course of operation. Then you can actually have certain shutdown operations that could potentially be executed on the edge, because you're now having this dongle capability, which is, or the onboard diagnostics connector, which is already plugged in to your diagnostic port, and you can actually have shutdown commands that could be issued through that. So you can actually do it through the onboard diagnostics already. You can have remote shutdown capabilities. You can bring the vehicle slowly, decelerate it slowly to a stop before shutting off the engine. You can actually do these controlled shutdown situations. Yes, you want. I'm sorry, I misunderstood your earlier question. Yes, you can. Rahul asks, OBD monitors or controls? So from my understanding, at least back when I was dealing with J1979 and 1939 technologies back in the early 2000s, you could use it for control as well as monitoring type of operations. It really depends on the type of security setup that is there. And I must confess that I've not kept up with how that technology has changed in the intervening 10 or so years. That is something that I'll have to defer to my product management team. So if your question is, is the OBD used only for monitoring or also for controlling? As of my knowledge of about early 2000, when I used to work for Cummins Engine, my understanding was yes, it can do both. However, a definitive answer I'll have to get back to you on, Rahul. And CY asks, Nitish says, excellent session. Thanks a lot. Thank you very much for attending. I hope you found it useful. And I hope you're able to make use of this. CY asks, does this application or cloud only for corporate users or small users also? Answer is both, really. Because the whole point of having these type of solutions in the cloud today is that you can start small and then grow with, the cloud can actually grow with you. So the solution is available for both small operators as well as large ones. Naturally, being fairly complex interactions to set up between the two, there is probably a small minimum size that you may want to have your fleet at, so that it's a worthwhile endeavor for you to do this integration. I would say somewhere between 5 and 10 trucks is where the minimum size of such an operation should be to get started with making an investment in this type of a capability. But the answer is yes, it's not just for corporate users only. Thanks again, everyone, for attending. I hope you found it useful. And thanks to Intel as well for sponsoring the session. Have a great day, everybody.